And that is why, as you ascend to higher altitudes, the horizon drops. Because you're viewing a sphere, you must look down to see the curved edge of the Earth.
That's just not true. I've been in aeroplanes and I've seen footage of high altitude balloons, and no matter how high up you go, the horizon stays perfectly at eye level.
That is a common misconception, Natalie. It is an optical illusion. Refraction at the boundary of the atmosphere makes it appear to be at eye level, but that is physically impossible on a sphere.
If it's an illusion, how does it happen at every single elevation? If I'm at 10 feet or 100,000 feet, the horizon is always 90 degrees from my vertical. If I was on a ball, my angle of depression to the horizon should increase the higher I get, surely. Why is the illusion so perfectly calibrated that it compensates for my height every single time?
You are ignoring the mechanics of light. Atmospheric density causes light to bend. It's a standard refractive index calculation, Natalie.
A calculation or a rescue mission for the globe. Because if you have to invent an optical illusion that works perfectly at every height just to keep the horizon from dropping, then you aren't using physics, are you? You're using an excuse. If the horizon always rises to meet your eye level, it's not because the light is bending. It's because you're looking across a flat plane.
The Earth is a globe. We have thousands of pictures from space proving it.
Pictures that are stitched together from a wide-angled lens, composites. We both know those lenses distort everything at the edges, and I'm talking about simple geometry. If the Earth was a ball, the math is simple. The horizon must drop. And if it doesn't, it's not a ball.
I am a teacher. I am relaying the accepted measurements of the scientific community. You cannot just decide the world is flat because you don't understand perspective, Natalie.
I understand perspective perfectly, Mrs. Globell. Perspective dictates that things disappear at the vanishing point, not by curving over an edge. If you had to look down to see the horizon, I'd believe you, but you don't. And since you can't show me that drop, maybe you should ask yourself why you're so committed to a model that requires an illusion to work.